Hello students, welcome to my channel Maths Hub. So today in this video, I'll tell you about the results on odd and even functions. So we need to know that which functions are even and which functions are odd and which properties help out in developing the Fourier series of these expansions, right? So now let's focus on the concept. So what is an even function? An even function is such a function in which when you replace x with minus x, you get back the same function. That means for any function to be even, f of minus x should always be equal to f of x, right? So if I check it graphically, it means that the function should be reflected about the y-axis. That means if the function remains unchanged when it is reflected about the y-axis, then that function is an even function. We can also say that the function is symmetrical about the y-axis, right? Now, what is an odd function? When on substituting x with minus x, if we get the negative of the function back, that means f of minus x is equal to minus of fx, then we declare that function to be odd, right? So in this case, graphically, we say that the function is symmetrical about the origin. That means the function is unchanged when it is rotated 180 degrees about the origin, right? So you can check any function either using the method you substitute x with minus x. If you get back the function, it is even. If you get back negative of the function, it is an odd function. And second method of checking is through the graphs. So if it is symmetric about the y-axis, it is a even function. If it is symmetric about the origin, then it is a odd function, right? Now, what are the properties, the integral properties of even and odd function? So let us take an example. So you can see that we have drawn the function f of x equal to x squared plus 6. And you can see that if I replace here x with minus x, what will I get? I'll get minus x whole square plus 6, that is x squared plus 6. So that will become an even function because we are getting back the same function, right? Now, the next function that we have is f of x is equal to x cube minus 8x. So if I replace x with minus x, what will happen? I'll get minus x whole cube minus 8 times minus x. So that is minus x cube plus 8x. So I can take out minus sign common and I'll get x cube minus 8x, right? So what are we getting? We are getting negative of the function. So this is a odd function, right? Likewise, if I want to check the third function f of x equal to x4 plus 3x square, you will find that when we replace x with minus x, then x4 minus x4 will be same as x4 and minus x whole square will be same as x square. So you'll get back the same function. So therefore it is a even function, right? Okay. So now let us come to the properties of even and odd function. So if a function is even and we have the interval to integrate is minus a to a, then it is always 2 times 0 to a f of x dx, right? So what happens is that we are saying that a function is symmetrical about the y-axis in case of an even function, right? So suppose if I have this type of function, you can see that this function is symmetrical about the y-axis, right? So if I have to integrate over the interval minus a to a, so this area, integration is basically area under the curve. So both the areas are same. So instead of calculating it from minus a to a, we can just calculate it from 0 to a and we can just take its double. So the property says that minus a to a integral f of x dx is 2 times 0 to a f of x dx, right? And likewise for an odd function, what will happen? We know that a function is symmetrical about the origin. That means it remains unchanged when you turn it by 180 degrees. So what will happen? This area is same as this area, but they are opposite signs. This is plus and this is minus. So when you will add the two areas, suppose this is from minus a to plus a. So when you will add the two areas, they will be same and they will be of opposite signs. So they'll get cancelled out and you'll get the resultant equal to 0. So this is the case when the function is an odd function. So we will be using these properties when we will be calculating the Fourier series of even function or odd function, right? So I hope you understand the concepts, right? And if you like the video, do hit the like button. And the next video will be on the Fourier series of even and odd function. So those of you who have not subscribed to the channel, do subscribe my channel to get the latest updated video. So believe in yourself and you will be able to succeed. Thank you.